please welcome Dr. Inga von Bibra, member of the Executive Board of Microsoft Germany.
Thank you, and welcome to our premises here in Berlin. I always find it's a very nice venue, not too large, not too small. I hope you had some good conversations already in this really interesting topic. I would like to share a few things about general AI with you today, and also the impact it already has and it might further have on the automotive industry. And maybe before we go into more detail, doesn't click. Try again. Regie. Here we go. I would like to just show some of the current activities with you. This is a construction site of a data center. Question for me to you, do you roughly know how many data centers currently are being built by Microsoft? Any ideas? Any order of magnitude? 5, 10, 1,000? 15? 50 per year, you're saying? Or what time frame? 20 per year, okay. Well, you know, AI is a key topic for us, and we're really in with attention on that, and that also means investments. We're actually building 120 data centers in 12 months. So if you break that down, I mean, they're all the size of a soccer field, several soccer fields typically. They're around 400 to 500 million to build them. That means every 3 days we are opening a new data center somewhere in the world. Means also per week, roughly an invest of 1 billion euros. So that's also, we've become, I always like that fact, we've become the biggest construction company, I think, in the world. We kind of have 120,000 people building data centers. So that's certainly not in-house capacity. We're outsourcing that, but you see the magnitude. And it's just not a magnitude of invest, it's a magnitude of demand signals that we're receiving from the market. So is AI really the next big thing? And I would like to put it a little bit into context. There are certain technologies, looking at almost the history of humankind, there are certain technologies, they're called general purpose technologies, that have a very fundamental impact, a really pivotal impact on economies, on a global scale, international scale, and really change society and the way we work. And what you see on this slide is that there's two things that are accelerating rapidly. One thing is the numbers of innovation and the acceleration of innovation cycles. See, you know, when you start off printing press, 1480, can't quite remember, and then the number of innovations in recent times, and also the impact it has on GDP growth. So what we see, it really has impact on the growth in various industries. And the typical examples for these general purpose technologies are that they don't affect just one sector, so you get better by inventing something. They actually affect multiple sectors. They also have something that's called a spilling over effect. So it's not just helping to benefit in that industry where it's been invented, to benefit to the business there, to benefit to innovation, but it actually spills over into other segments as well. So a typical example, if you think, let's take the steam engine, or let's take electricity. When electricity was discovered, Benjamin Franklin probably thought, well, that's a cool thing, but did not have completely in mind what it does with us, all the way now to leading up to us having smartphones. And the third part, and I think this is very important to keep in mind in this transformation that we're facing, these technologies, they have a lot of difficulty in the transition. So there's a lot of overhead, difficulty getting it started. Think of railroads. So you invent the steam engine. The time we actually built railroads took some more time. Back to electricity, it wasn't just the flip of the switch. There was light, then we needed to put in infrastructure. Where does the energy come from? Power plants needed to be built. And it also means it's a change in technology. Technology becomes obsolete with new inventions, but also a change in skills. Once you drive cars, you don't need horse riding anymore, or you don't need as many, let's say, typical typewriter, all the writers who wrote things by hand. And I think this is something that we're seeing also with AI at the moment, because it automates things, it changes the way we work, and there's quite a bit of change in the system in terms of what technology will we continue, what skills will we continue, and are we fast enough in building the new technologies and the new skills. So the answer looking at this is Gen AI as such part of these general purpose technologies? Yes, it clearly is. And it will change the way we work. And it is already the fastest adopted business technology ever in history. Let it be on believing in it. 87% already believe it gives them a competitive advantage. Majority of companies have realized they can actually add new value with it. It's not just getting better at what they're doing, it's actually doing things differently, generating additional value. And if you had about cost and cost pressure, IT spend, I think in all of the industries, in the industry we're talking about here, we know that is not abundantly available. So rededicating 43% of IT spend towards AI, and that's the prediction going forward, certainly shows that there's a lot of faith and attention in this topic. And same applies to automotive companies. So the automotive companies that adopt Gen AI now, they do it across the whole value stream. So you start off, you think of engineering and design, with helping to have multimodal views on augmenting the design process, requirements, specification, requirements management. But it's also about production and supply chain, being suddenly able, and I think that's the difference. AI is long and old, right? 1954, I think it was invented the first time. But now, with generative AI, it has changed into the way we interact with data. So we actually are able to talk to the abundance of production data there is in order to find out which plants are outperforming other plants. Where do we see certain patterns? And not through clumsy cockpits, but rather in natural language, or also in natural visualizations and reasoning. Same applies to sales, service, and marketing. A lot of efficiencies, improvements for quality, and looking at the cost again, of course, also in indirect functions, where there's a lot of overhead that, particularly for the European OEMs, has always been a problem in comparison to other countries and competitors. Also, there's a lot of potential here to improve this. So let's have a look at how generative AI can really, in the automotive space, help to have a significant impact. And I think the key differentiators, and I liked your presentation on also in the Americas and in the Asian space, what we see is what is key in terms of being successful is fast innovation. So far, we are not that fast in terms of innovation due to complexity we need to manage, regulations we need to manage, and improving there, absolute key. The second one is also how fast are we getting features into production? That's on the hardware side, but also on the software side. How fast can I, over the air, update a vehicle without actually causing a safety issue? How differentiate that in the architecture? Customers have different expectations, and coming from a traditional 7, 8, 9-year development cycle of product development, the new competitors have significantly shorter cycles of 2, 3, or 4 years. And of course, in terms of operations, customers expect a different dialogue with their, let's say, their vehicle, their hardware, similar to what they're used with their mobile phones. And also that, let's say, customer centricity in the way products and OEM look at the customer, rather than coming from this traditionally quite engineering and product focus of German OEMs. So if we look at, for example, at requirements management, you know the challenge, and you also know how complexity has exponentially, almost like blown up over the last few years. And this is also because There's, first of all, even on the mechanical and the regulatory requirements, with 50,000, that is a lot to deal with. With the software and electronics requirements, we're talking 500,000, and if we now look at the lines of code that we need to manage in modern vehicle software, we're talking 200 to 300 millions. I think I looked up the first Volkswagen that was built, had something like 2,000 lines of code. And that is a complexity, I think, that we see where processes, systems, and people are struggling to keep up. So 8 hours per requirement for the standard requirements engineer to deal with that, from draft to review, refinements, and we also know that tool chains aren't always integrated. There's a lot of manual work also moving in one tool chain for the E-part to the other one for software and so on. With generative AI, this can be reduced by at least 20%. It helps to automate interface, it helps to have smart suggestions on how to proceed, on next best definitions. And interestingly enough, a lot of the generative AI tools that people are using, the first point is always, yes, it helps me to increase my productivity, but in truth, after experiencing it a little bit longer, it actually comes, number one becomes, it helps me to deliver better quality. And this is the case in engineering. This was a case also from a more on the financial services side, where people said, it really helps me because I can bring up my quality. And of course, also, see a little symbol down there, the time saving in software development, because a lot of these actions, it's actually not something that engineers are paid for or qualified for. It's the boring work, right? It's in software development too. It's like documentation and retesting and copying the code and putting this and linking that. So with intelligent Gen AI tools, you can really bring the fun back to the developer community and help them to focus on what is truly important and what also corresponds to their core competency. In product design and development, if we see that very significant global R&D spend, obviously there's a huge potential for savings and efficiency. And we start from the right on the slide. I mean, it's not surprising. Engineering executives, I think every executive will always tell you, oh, we absolutely have room for productivity increasement and so on. But if you talk to engineers, I mean, they really struggle. They really struggle to meet their timelines. They struggle to have the pressure and integrate everything. There's great studies showing that 51% of automotive development projects are over time and 44% are over budget. And I think everyone has probably experienced that reality in the industry. And that is also because 59% of these engineers, they spend their time on non-value adding tasks. So just imagine what you can achieve if you just take half of that away from them and reinvest that in the increase in productivity and a better reuse of that R&D budget that's there, that can go into new features and reworking architectures and being more competitive. And last but not least, customer service management. I believe closer linked to software than we always think, because a lot of data around the customer and around customer service is information that we need from the vehicles that come out of the cars. And there's a lot of efficiency and potential in both quality as well as handling time across the process. Because agents, I mean, we all know it's probably a job that is super stressful, inconsistent service, and also as people, we actually sometimes don't even want to talk to people. We just like having that chatbot on hand. We get predictive service, we get a single source of truth, and we can do it at our own time, and it scales, right? You don't have to be in a call center line for 10 minutes because everybody's trying to call. You can just talk to someone straight away. So there's also a great potential there. One thing I would like to add, we tend to talk a lot about efficiency and also about quality, and we think of these Gen AI tools, which they currently are, or applications that we build, in a first step around your own, let's say, area of work. What's happening, though, you have to imagine these Gen AI products as agents. So when you think of process automation, think of like a virtual colleague that's basically running a similar job in the background talking to other agents. So you can imagine an engineer in R&D talking to an engineering agent on the production side to get that interface straight between R&D data and production data, for example. You can think of, in the finance department, an agent helping to analyze the data and also then trigger action in other agents and other departments. So it's not just stupid process automation, it's the intelligence behind it that takes a share of business processes out also into this agent world, which then again helps to help scarce engineering talent to build this, to transfer more into their core competencies and go back to adding the true value that everybody's been educated for. So the impact goes along the complete value chain. I've touched a little bit on engineering, but you can also see that in blue screen, I guess my time's up, but it's nearly finished, across the value chain with significant improvements there. And you would be surprised to see how easy it actually is with data scientists and the right language models, even with smaller language models that don't need as much compute power, that are faster, to build these agents in the requirements engineering space. We have seen some cases where a consulting firm managed to, with just 4 data scientists, build a really interesting agent based on an open source model. So people are getting started, and I think we'll just go to the next one now. We talked about the traditional hardware-oriented industry here, and we also had a look left and right into software and also the new competitors. I think it's an exciting future that's coming up, but it also means it's key to embrace the technology now. People are already doing that. Companies are doing that. Competitors are doing that. Other countries are doing that. And I think the democratization of AI with this, also in this space, has already started. And I'm looking forward to seeing a lot more of this in the next 12 to 18 months. Thank you.
Thank you, Dr. Inga von Bibra. Are there any questions?
Thank you for the very impressive presentation. I have 2 questions. One question is, you gave us an impressive number, 120 data centers in 12 months. Mm-hmm. Can you give us a little bit more on an insight, how you decide where you place it all over that world? And secondly, can you give us a number about how much energy one of those data centers is consuming when it's in operation?
Yeah. So the decision processes, I'm not part of decision process on where data centers are built. I think we have a good example in Germany, though, that with in the former coal area, the big investment was strategically placed simply because of an area that has labor, that has certain proximity to other big network nodes, that has also a potential to attract more industry in that space. So in that sense, here the decision was clearly made around of course there's also geophysical aspects you need into consideration. I'm not an expert on that. So in that sense, and I think that's transferable to other countries as well, where are there also from a specific local area in terms of also driving the development of certain regions potential, plus then of course the connectivity. Your answer on the electricity consumption, I can't give you numbers, don't have them. I would like to point out though that the ambition of Microsoft to be CO2 and water neutral, so the sustainability goals remain, even though, of course, it has become more challenging. We need to be more creative in terms of how to meet those. But there's still absolute commitment to be carbon neutral 2025 and negative 2030. No change there.
Yeah, thank you very much for the nice presentation. One question regarding data. You have a lot of data centers worldwide. Now we have a lot of regulations also worldwide with data. How do you cope that, especially with China? And do you also offer solutions for customers so that this can be easily taken into account?
Absolutely. I mean, I think it's a top topic. It's becoming probably even more burning every day. Particularly, maybe also we have seen some evolution on the geopolitical front. For Europe, first of all, there are data centers in every region, so regional concepts for Europe in Ireland. So it's really on, let's say, sovereign space, not all hosted in the US. That's first of all, you can go into your individual regions. And then, of course, you follow the local data protection laws there as well. Same for Germany. So we have, obviously, Frankfurt has big data center, now the new one's being built. The topic of sovereignty, I think that is the key for many of our customers who also might have concerns about access indirectly through an American company and so on. Depending on the information classification, we actually have for data that truly requires sovereign hosting, there's a new offering. It's called the Delos Cloud. It's actually a joint venture with SAP to offer basically an Azure stack and an Azure data center in a completely separate non-Microsoft unit operated by non-Microsoft people. It's basically Microsoft technology, but operated completely without Microsoft. That's the Delos Cloud, and that's an offering that's on live, I think, or the announcement was made a month ago. So here we're talking customers that have extremely sensitive data. That's on similar constructs we have around the world, because you can imagine if you talk federal, if you have certain American units also, even if they're in America, they would like the federal agencies we have there, they have certain requirements on data protection. So we cater for those. In Germany, it's the Delos Cloud. In France, a similar offering, it's called Bleu. That takes care of that. So depending on information classification, of course, these things come with an overhead in terms of management and maybe a lag in terms of innovation. We advise customers to be super stringent in their information classification and then use what matches their needs the best in terms of cost and requirement ratio there. Yeah.
Oh, there's another question.
My question goes to the energy consumption, like my previous talker. Last week or 2 weeks ago, I heard that AWS Cloud working on a private nuclear plant to supply the energy for the cloud centers. Does Microsoft want to go in the same direction?
Not that I'm aware of, and no plans there. No. Not turning into a nuclear power plant provider.
Thank you, Dr. Inga von Bibra.
Thanks.
Let's grab a coffee.